right? So we set the two equal to each other. And here's where we are. We're going to add 1 to both sides. So 4x is equal to 8. X is equal to 2. Now, what's different here? So the thing with logarithms is you have to check for extraneous solutions. Not all of the answers that you get are actually going to be ones that work. So what you have to do is to check your work, to check the answer, you have to plug in what you got into the very, very original equation.
For everyone?
For everyone. You have to, like the first, the original, right? If you plug it into here, it's going to work. All right? It's always going to work. So there is nothing there. You have to plug it into the one with the logs. So now, the way this works is, okay, log base 3, 5 times 2 minus 1. Is this the same as log base 3, 2 plus 7? Right? So in the first case, I get log of 9, log 3 of 9. Here I get log 3 of 9. Yes, they're the same, so that's a solution. Okay? Yeah, because if you don't check and you don't see, and it's not a solution, but you said that it was, then you can't get full credit. Okay, here too, you have log base 2. We're going to set the insides equal to each other. So this will be 2x equal to x minus 2. I'm going to subtract x. X equals negative 2. Okay, when I check, right? When I put negative 2 in here, what do I get? Log base 2 of negative 4 equals log base 2 of negative 4. Okay, so what do you think? You got the same thing on both sides, so does that work? Well, what's log base 2 of negative 4?
Oh, it's no solution.
It's no solution because, yes, they're the same, but you're never allowed to have a negative in a logarithm, so it fails. So this is no solution.
Because there will be no solution equals no solution.
Right. You can't have negative inside log. All right? So those are the things that you need to watch out for. Okay. So that was the first case where you have a log on both sides. Now, if you have a logarithm on one side, right, you want to use the concept of exponents. So look at this one. What is that? Can you turn that off? The first thing you want to do is isolate the ln. All right, how am I going to isolate the ln here? Divide by 2. So now, ln of x is equal to 9. Okay, so here I have ln of x is equal to 9. Now I have a logarithm only on one side of the equation, right? So for this, I'm going to solve a different way. I'm going to use the properties of logarithms. So do you remember what is the answer to a logarithm always? The answer to a logarithm is always a what? Exponent. So this is an exponent, right? Now, every exponent needs a base. What's the base here? The base of the ln is what? E. So I say e to the 9 is equal to this other number x. Okay? So remember, what were we doing before? If I have log base 2 of 32 is equal to 5, what's another way for me to write that? Base
5.
Base to the power is equal to that number 32, right? So same thing here. Base to the exponent is equal to that number x.
What's in the problem?
This?
Yeah.
It says exponent.
Oh, okay.
9 is the exponent. Every exponent needs a base.
So then
E to the 9 is equal to that number x.
So then
So now, e to the 9 is a very large number. Usually when you start getting into the 4-digit numbers, you don't have to multiply it out. You could just say e to the 9. That's good enough. Okay? Okay. Here, let's do the same thing. Let's isolate the log first. So minus 7 on both sides. That gives me negative 3 log 10x equal to 6. Now what?
you could still isolate it.
You could still divide by negative 3. Log 10x equals negative 2. Now the log is isolated. Now I need to use properties of logarithms. Where is the exponent?
The 2.
The 2. Every exponent needs a base. Where is the base in this problem? It's the 10 here that's hidden, right? So I say 10 to the negative 2 equals what?
X.
Not x.
10x.
10x, this whole thing.
And then you divide.
Okay? 10x. Now we're good. Now I need to solve for the x. So what am I going to divide by? 10. Divide by 10, divide by 10. So x is 10 to the negative 2 over 10. And now we have to do some, algebra 1 here.
It's 10 to the, it's negative 2 minus 1.
Right.
Negative 3, which is, which is 1 over 2.
That's it. That's one way of doing it. Or you could say 10 to the negative 2, that has a negative exponent. It must move down, right? So it moves down. So you have 1 over 10 to the 2 times 10.
Why?
Okay, this 10 is already here. The one from the top, 10 to the negative 2, has to move to the bottom, and it becomes 10 to the positive 2. Together, it's 1 over 1,000. Okay, so this is what I was going to say now. I really haven't been doing this. I am not setting a good example, but you have to be checking every single one. All right? So let's see if this first one works when you check. No. No, look. 2 ln of x e to the 9. Is this equal to 18?
Oh, yeah.
All right, what ln of e will go away here. So 9 comes down.
Oh, yeah.
9 times 2 equals 18. Oh my God, it's like magic. All right? Well, does the 1 over 1,000 work? Let's see. 7 minus 3 log 10 times 1 over 1,000. Is this equal to 13? Okay, let's see.
Well, that's 1/3.
Let's see. 7 minus 3 log 1 0 cancels with 1 0. So you have 1 over 100. Does that equal to 13?
No, it doesn't.
Do you need your calculator? Let's see. Okay, so this is 7 minus 3. What does this give you? Wait, this will be on a non-calculator.
So
Just this part in the circle could show up on a non-calculator section.
2.
Base is 10. 10 to the negative 2 gives you 1 over 100. So that's negative 2. Does that equal 13?
No way.
What's negative 3 times negative 2? Positive 6 plus 7, 13. Okay? All right, let's do one more. Logarithm on one side, so we have to do base and exponent. Where is the exponent? Where's the exponent here?
20.
20. Exponent is what? 20. And the base is 5. So x to the 4 is equal to 5 to the 20. Now I need to solve for x. What am I going to do?
Do the root thing of 4.
Fourth root. Yes.
Can you go back to start that? I'm so sorry.
So log on one side.
Yeah.
This is the base. That's the exponent.
Yeah.
So 5 to the power of 20 is this that I haven't used yet. Okay. Fourth root. Fourth root.
So you can also do x and then it would be x 5
Okay.
times
Right. So now
1 4.
right. So x is now, look at this. 5 to the 20th. And what's fourth root? Is that the same as to the power of 1 over 4? It is. Liel, question?
Didn't you just make it to the fourth root?
I did. Another way to write fourth root is to the power of 1/4.
So
You could have done to the power of 1/4 from the beginning.
Isn't it 5 to the 5th?
Yes, it is. X is equal to 5 to the 5th. Okay?
Which is some 125.
That's a large, no, 5 cubed is 125, huh? No, it's
No, it's,
much
it's the one after 625.
You can leave it as this. It's 625 times 5. Okay. Log base 5, log base 5. I'm going to set these equal to each other.
Can we put it
Okay. So when we do that, we get x squared plus x equals 20. And now this is a quadratic equation. And how do we solve quadratic equations? Subtract 20 and set it equal to 0. If there is one thing we can take away from any math class, it's quadratic equations factor that way, right? Now I can factor
It's minus 5 is
x plus 5,
minus 4.
x minus 4. Plus 5 and minus 4.
No, because there's a 1 from the x and it has to add up to 1. And
Correct.
It has to multiply those negative
So
20.
you need two numbers that multiply to negative 20 and add to 1.
Yeah. Okay.
And that's 5 and negative 4.
So then x equals negative 5 and x equals
So
4.
x equals negative 5,
Okay.
x equals 4. Now I need to check both of these, right?
Oh, yeah. Okay.
So x equals negative 5. Okay, look. We're going to have log of 5. Okay, I'm going to put negative 5 here, and what am I going to get? Negative 5? 25. Plus x, so plus negative 5 minus 5. Does that equal to log of 20? It does. Woohoo! Well, what about x equals 4? Surely that's not going to work.
No, it'll definitely work.
You think so, huh?
I think so.
Okay, so 16 plus 4. That does equal log 20. Oh my word, they both work.
So let's say one didn't work.
You throw it away.
Would you say that's correct and we have also no solution?
No, you don't say no solution. You just cross out the one that didn't work, and then in the answer space, you just write down the one that did work.
So this one.
So you can have. So you see here, you can have the case where you have 2 and they both work. You can have 2 and 1 works. You can have 2 and they both don't work. Okay. All right. Let's do this next one. This next one's a little bit different, and I'm holding true to what Liel said, and we're different situations in each problem. Okay.
I am.
Okay. Log base 2 of 5. Now, what's the problem here?
You have to condense.
You have to condense these. But we like condensing because it's so much fun. So 1 logarithm. You write the first one, then because I have a minus, this goes underneath.
Oh, yeah.
Yeah. But since you have identical logs, you can just set their arguments equal to each other. And now, yeah, you have the LCD is x minus 4 of both of these. So you can multiply both sides by x minus 4. Hang on now. 5x minus 4 is equal to 10. 5x minus 20 is equal to 10. And now I think I'll add 20 to both sides.
It's 6.
You guys have beat me to it already. 5x is 30,
But then we have to check.
and x is what?
I actually checked it. It wasn't that hard. I thought.
But then you have to check. So when you check, where do you plug it in?
To the one that's condensed.
To the one that's not condensed.
It works.
It may work, and then there are cases where it will not work. You have to go back to the original, because if you check it here, it could be that negative will cancel out, you know, and so you don't get the right information. So when you go over there to check, log base 2 of 5 equals log base 2 of 10. Man, I love math. Minus log base 2 of 6 minus 4. We have some skeptics who say it doesn't work. Well, let's see. Let's see. Is this going to work or is this not going to work? This is such a it's like the,
I don't think it's gonna work.
oh my.
No, it didn't work.
No.
See,
No,
this
it
is it.
doesn't.
It's
Wait.
like the climax of this plot now. Okay? What's going to happen? Okay, so log 2, that's like the most interesting part of the movie. Log base 2 of 10 minus log base 2 of how much is this?
1. It just, you could put 1.
What is 6
No.
minus
No.
4?
It's
2.
No,
It's
but
two.
it's 2 log 2. So you
Okay, but.
It's a negative.
But
5 equals 8.
log base 2 of 5, can I condense this?
Ah.
Log base 2, 10 over 2, and how much is that, guys? It's 5 and it
I
works.
condensed it before I like switched it before. I totally didn't see that.
See that?
Didn't see it coming.
Plot twist. Plot twist. Okay. You like it, don't you? Huh?
It's kind of screws with my head.
Well, you know, this is it. We gotta work. And you know what? There is a certain comfort when you can like put all your faith in the math, because like you see how like it's like it's bigger than you. Okay?
Oh, of course.
All right. So let's move on to one more.
So you
Hold on.
condense that.
Let's move on to one more. We're gonna condense this.
You basically have to condense number possible.
Log 3x
Okay.
x plus 2 equals 1.
You condense number possible.
You condense because you're not allowed to have more than one logarithm on each side, on a single side. Now, here I have a log on one side. That means I can't do the, equaling to each other. I need to do the properties of logarithms. So look for a base, look for an exponent. What's the base?
1.
No?
No.
10. What's the exponent? 1, positive 1. So 3x, x plus 2 is equal to 10 to the 1. You see that?
And then we have to condense.
Base, exponent equals this number. Base, exponent equals this
What?
number.
The 10 to the first is 1? No?
It's 10. 10 to the power of 1 is 10.
Then why are we getting 10 there?
10 is the base?
Yeah.
Okay,
Oh.
so
But then isn't anything to the power of 1 0?
it's 1.
1. So then.
Okay,
to
so
the power
then,
of 1 is 1.
correct. So 3x squared plus, it's 10, sorry. 3x squared. Okay, look, here we have 3x squared plus 6x. Here I have 10 to the 1, so it's 10.
Yeah.
Okay, now, quadratic equation, so I bring everything over to the left side, set it equal to 0. Can I divide everything by a number, by the same number? No? No.
Yeah, by 2. No?
We're going to try to factor. So let's see if it works, by, that method, x squared minus 6x minus 30. Are there two numbers?
5 and 6. So,
Okay, so hang on. I need two numbers that multiply to 30, and you get, and they add to 6. So let's do this. What are the...
15.
How's that add
Oh.
to 6?
I don't know.
So 2 and 15 doesn't work. 1 and 30 doesn't work. 3 and 10? No. 5 and 6? No. Okay, so sorry guys, this can't factor. Quadratic formula it is. Oh my god, this is getting more and more fun.
Love it.
Okay.
I hate.
So,
You do a lot of things.
I said I.
okay.
I didn't say I hate.
X.
Thinking in my head.
Okay, so x is equal to
6
negative b, that's negative 6, plus or minus the square root of b squared
6
minus 4 times 3 times negative 10.
Why negative?
Well, we have a lot of these on the test.
It's a surprise.
No, I thought chapter 3 was so easy. And then this came along.
So, it's okay. So negative 6 plus or minus the square root of 36 plus, okay, so here I have 12 times 10 is 120 over 6. Not 2 times 3. Hang on. So this is negative 6 plus or minus root 156 all over 6. Okay, so why don't we see if we can factor 156? It's 2 and how much? 140 is 70, so 78. Okay?
Are we like?
And this is 2 and 39. Okay? So, remember,
So it's
any of these numbers who can find a partner can come out. So let's see. Let me just set this up first.
-6 plus or minus.
The 2 comes out, and the 39, which couldn't find a root, stays in all over 6. Keep writing 2 there.
Can we cross out? Oh, never mind.
Now, you can divide everything by 2. You can divide everything by 2. So, negative 3 plus or minus root 39 over 3. Now, because you have a 6 here, a 2 here, and a 6 here. So you can divide it all by 2. Now, here's the issue. We have to check this. Ugh, I keep writing 2. We have to check this, okay? But I know it's a pain to check. So here's, look. Here I have log of 3 times a number, 3x. Can x be a negative number here?
Yeah.
If x was negative and I did
No,
log
yeah.
3x, that would be log of a negative number, and that doesn't work.
Oh, you're right.
So take a look at this. We have 2 solutions here, right?
Yeah.
One is negative 3 minus root 39 over 3. One is negative 3 plus root 39 over 3. Is this going to give you a positive or a negative value? Negative. So you could just throw that out and just take this.
What's the answer?
Negative 3 plus root 39 over 3.
No.
It's fine. We're not going to check that one. Okay. Here. Okay, so here we have to condense this. So you're going to start off that way. So log base 4 x plus 10 equals log base 4 3x. Now I can set the 2 equal to each other. So it's x plus 10 equals 3x. When I distribute, x squared plus 10x equals 3x. Now, I need to subtract the 3x over to this side. So, when I do subtract the 3x,
We wouldn't make it
7x, okay, minus 3x, so that's x squared plus 7x equals 0. Okay, now I'm going to factor out an x, Correct. So how much is x?
0 and negative 7.
0 and negative 7. Okay, let's check these guys.
So I don't have any room here, so do I still have to check if I don't have room here? But...
So x equals 0, right? That gives me log base 4. And now look, 0 plus 10, 10. Plus log base 4 of 0. How much is log of 0?
1. Yeah. Wait, 1.
Oh, 1.
What's the question?
Log of 0.
1.
Log of 1 is 0. Log of 0?
0.
No solution. So, and then if you continued, you would get log base 4 of 0.
So then it's the whole thing, no solution?
So this, okay. So, no solution. So this one doesn't work because log of 0 is impossible. It's out of its domain. So what you do is you just cross out the x equals 0. Now, move on to x equals negative 7. This is going to be log base 4. Here, I'm going to get 3. Okay, fine. Plus log base 4 of how much? Negative 21. There too, that didn't work. You cross that out too. Because both of them did not work, this problem has no solution. All right? Okay. This one here, can we set them equal to each other?
Yeah.
I can. So 2x squared plus 1 equals, correct. Bring everything to the left side. 2x squared. Because it's a quadratic equation and I need to solve it. 2x squared minus 10x plus 8 equal to 0. Now here, look, I can factor it like this, but it's more difficult as opposed to if I were to divide everything by 2, right? Because it's a common factor. Divide by 2, divide by 2, divide by 2. So x squared minus 5x plus 4 equals 0. And, okay, this thing factors. Two numbers that multiply to 4 and add to 5, 1 and 4, negative 4, negative 1. So, x is 4, x is 1. Then we have to check. So let's check. X is 4. Log base 2. Okay. 2 times. 4 goes in here and I get 16 plus 1. How much is that in your head? 33. Does that equal to log 10 times 4 minus 7? 40 minus 7? 33, it works. Oh my God, yes. Okay. Next one. Log base 2. 2 times 1 plus 1. How much is that these days? 3. Does that equal to log of 10 minus 7? Yeah, it works. So both of those are solutions. Okay? Okay. So go ahead and do the next one. You're going to get a quadratic equation, which you then have to solve using the quadratic formula. Okay? I just ruined the ending for you, but it still works because you don't know how cool it's going to look. Okay, go. Okay.
It's not 60 minus 60.
16 plus 16.
Mm-hmm. Yeah, I don't know. What is 16 times 2? 32. Yeah, I don't know.
And the last one, J, you don't have to do it. It's actually a repeat from before.